So we are going to talk about slope, and yes, you did do it last year. So it should be somewhat of a review. I always think we don't need to cover this, but I really always need to. And so anyway, so today we're just talking about slope, and we're going to talk about parallel and perpendicular lines. Slope takes on a lot of different faces, so you need to be able to recognize it and understand it in several different ways. Slope is something that is used in all different aspects of life, honestly. If you build a house, your roof has a slope, which is called a pitch. If you work in the business world, you look at trends over time. Your sales are either increasing or decreasing. It's just used in a lot of different ways. Slope is the vertical rise over the horizontal run. It also has a formula associated with it. We use the letter M to represent slope, and it is the difference in the y's over the difference in the x's. Now, the order doesn't matter as long as you subtract both the top and the bottom in the same order, okay? And we'll talk about the difference in that here in just a moment. So, like I said, it takes on a lot of different forms. Sometimes you have to be able to look at a graph and find the slope. Sometimes you're going to be given the ordered pairs, and you have to find the slope. And then sometimes you're given the equation of a line, and you have to rearrange it and put it in slope-intercept form to be able to identify the slope. So like I said, it takes on a lot of different forms. So let's look at the first one. And so if it's graphed, you need to find two good sets of points where it crosses at a good spot. And so if we look at those 2 points right there, we could go from one point to the other, and we rise and we run. So if I go from the bottom one to the top one, I rise up 2, which is a positive 2, but then I have to go to the left 1, 2, 3, 4, 5, 6. So my slope is a positive 2 over a negative 6. And what does that reduce to? Okay, so my slope is a negative 1/3. Okay, that negative can go on the top or the bottom or out to the side. All right, so that is looking at a graph to identify slope. Then we can be given a set of points, okay, where we have to use our formula, and it's the difference in the y's over the difference in the x's. And like I said, I don't care which way you subtract as long as you do the y's in the same order as you do the x's. The y's always go on top. So I could subtract 2 minus a negative 2 on top, and then negative 1 minus a negative 3 on the bottom. Okay, when you subtract a negative, it becomes positive, so that becomes 4, and then negative 1 plus 3 is a positive 2. 4 divided by 2 is 2. Like I said, we could subtract in the opposite order, where we do right to left, and that would be negative 2 minus 2. Again, the y's go on top. Negative 3 minus a negative 1. That gives me negative 4 over negative 2, which is also 2. Okay? So like I said, you can subtract left to right, right to left. It doesn't matter as long as you do both the top and the bottom in the same way, and you have to put the y's on top. Now, some teachers teach a method called stack and subtract. If I have any sophomores in here, your teacher might have done it like that, and that's just another way to do it, basically the same idea. That's where you take and you put one point underneath the other. Okay, if you had Miss Stevenson, she said go for a drive. So basically, we subtract negative 2 minus 2, and then we subtract negative 3 minus a negative 1, and you can see that it looks just like this one down here. Okay, that's just another way to set the problem up. Okay, I'm pretty sure that most of the 8th grade teachers did the formula. I may be wrong, but that's what my other class told me. Okay. Both ways? Okay. Probably would be to your benefit to remember the formula, I think, just as you progress on in math. But, I don't know that it really matters one way or the other. I will probably use the formula, but if you're more comfortable stacking and subtracting, then do that. That's fine. Okay? All right. Now, here's another one where we would use the formula. Again, we subtract the y's on top. So 5 minus 5 over negative 3 minus 1. 5 minus 5 is 0 over a negative 4. What is 0 divided by a negative 4?
0.
0. Okay. Another one. 3 minus a negative 4 over 4 minus 4. 3 minus a negative 4 is 7 over 0. What's 7 divided by 0?
Undefined.
It is undefined. Okay? If you were to put in your calculator 7 divided by 0, it's going to error. Okay? Let's think about it. If I had 7 apples and I was going to put them in 0 parts, would there be any place to put them? No, there's not any place to put them. Okay? Another thing that we want to talk about is what the graph of these look like. Now we can see that this one has a negative slope, right? If you look at it, if you read it like you would a book, it's decreasing from left to right. That means it's going to have a negative slope. This one has a positive slope. So it is going to look more something like that, okay? It increases from left to right. So it's going to have a positive slope, okay? So let's think about this. If I'm skiing, I'm going downhill. That's negative, okay? Here, I'm going to go uphill. I'm rising. If my slope is 0, I'm not going anywhere up or down. I'm just scooting along with my skis on, which is a lot of work, isn't it? Okay? All right? So when you have a 0 slope, it looks just like that. All right? Undefined is, you can't do it. It's impossible. It's got a slope like that. If you think skiing, you go straight down, it's not a good deal, right? And you can't go straight up without help, yes? Okay, so that is your undefined slope, all right? And I don't know if you've ever done a slope dance, okay? But your slope, your positive slope goes this way, your negative slope goes this way, 0, undefined. So positive, negative, 0, undefined. Do it with me. Positive, negative, 0, undefined. Again. Ready? Positive, negative, 0, undefined. Okay? All right. So that's the slope thing. Okay, now let's relate it a little more to what we've been talking about recently, parallel and perpendicular lines. Okay? If you think parallel lines, if you just look at a pair of parallel lines, their lines slant exactly the same, don't they? So what does that tell me about their slope? Their slope is the same, okay? The slope of this line is the same as the slope of that line. This is an undefined slope for both of them. They're parallel, okay? So when you have two lines that are parallel, their slopes are going to be equal, okay? And vice versa, all right? So anytime you have two lines that have the same slope, those two lines are going to be parallel to each other, okay? Perpendicular, all right? Now, you can see that this has a slope of 0. This one has an undefined slope, okay? A horizontal and vertical line are perpendicular with each other, okay? But what if it's not horizontal and vertical? What if it's, a positive and a negative slope? Well, if they're going to be perpendicular, they're going to have slopes that are opposite reciprocals, okay? So let's say this one had a slope of 2. Its reciprocal is 1/2, but it's going to be a negative 1/2 because they're opposite signs, okay? You should be able to multiply these two slopes together and get -1. That's another way to look at it. Here's another example of some that are, let's say this slope was 3/4. The line that's perpendicular to it is going to have a slope of -4/3, okay? So parallel lines have the same slope. Perpendicular lines, the product of their slope is -1, or you can think of it as opposite reciprocals. Okay, their slopes are opposite reciprocals of each other. So one's positive, one's negative, and one's inverted from the other. Okay. So we are going to determine whether lines AB and CD are parallel, perpendicular, or neither. Now, what happens when they're neither? They intersect, that's it, right? They don't intersect perpendicularly, because when they intersect perpendicularly, they create a what? Right angle. And when they're parallel, they never intersect, right? So if it's neither, they might, I don't know, they're going to intersect and somehow, but they don't create a right angle, okay? All right. So in order to determine if they're parallel, perpendicular, or neither, we need to look at their slopes. So we're going to look at the slope of line AB and the slope of line CD. Okay? Remember, difference in the y's over the difference in the x's. So we're going to do -5 minus 7 on top and negative 2 minus 4 on the bottom. That gives me negative 12 over negative 6, which is what? Positive 2. Then we're going to look at CD. So the difference in the y's, 2 minus a negative 2 over 0 minus 8. That gives me 4 over negative 8, which reduces to what? Negative 1/2. Okay, what does that tell me? Okay, they're opposite reciprocals, right? So they are going to be perpendicular. So I would write line AB is perpendicular to line CD. Don't forget, that's the symbol for perpendicular. That's how you would write that mathematically. Okay. All right, let's do another one. Again, we're going to look at the slope of AB and the slope of CD. So we have negative 7 minus a negative 4 over negative 8 minus 4. So negative 7 minus a negative 4 becomes negative 3. Negative 8 minus 4, negative 12. What is negative 3 over negative 12? Positive 1/4. Okay. Do the same thing with CD. Subtract your y's. Negative 5 minus 7 over negative 2 minus 1. That gives me negative 12 over negative 3, which is equal to what? 4. What does that tell me? They intersect. That's it, right? If this one's a neither. Now they're reciprocals. Why are they not perpendicular? They're not opposites, right? Okay, these are reciprocals, but they're not opposites. So this one would just be neither. They intersect, but just not in any way special. Okay, what do you think this one's going to be? Think so? Probably. Slope of AB and the slope of CD. Again, we have 6 minus 2 on top and 3 minus a negative 9 on the bottom. 6 minus 2 is 4, and this is 12, so that reduces to what? 1/3. Okay, and so then for CD, we have 4 minus 3, and we have 5 minus 2, which, yes, they are the same. What does that tell me? Parallel, yes.
Because it doesn't tell us what intersection, could there be the possibility that they are the same line?
Could, yes. Could, yeah. I would still put, if that's the only thing you have to go with, I would put parallel, yeah. Yeah, I don't know. Because they could be one line on top of the other. You could graph it to determine if you were worried about that. Don't think they would, just because, I don't know. Just because look at this point and that one, they're so close. And those are off. Yeah, I don't think it would be. So we would say that AB is parallel to CD. Again, that's how you would write that mathematically. Remember, that's the symbol for parallel. Okay. All right, we're also going to do some graphing. Okay. This one says graph the line that has a slope of negative 2 and passes through the point 3, negative 1. Okay. So it passes through this point 3, negative 1. So I would need to graph that first. Now remember, when you have an ordered pair, the first number tells you which way to go left or right. Second number tells you which way to go up or down. And you say, we know that, but yes, and sometimes when you're graphing points and doing slopes, sometimes you get them mixed up. It's happened. I've seen it a lot. Okay, so be thinking about what you're doing when you're doing it. All right, so I go from the origin, I go 3 to the right and down 1. Okay, so it's going to go through that point. And then it tells me it has a slope of negative 2. Remember, slope is rise over run. This is just the number. What do I need to do? I need to put a 1 underneath it, right? So that I can get my rise and run. So it's rise over run, so I have to rise a negative 2, which means I go down 2, but then I'm going to go to the right 1. Okay, and then I connect my points. Oh, that was terrible. Well, something like that. Could I have gone up 2 and to the left 1? Yes. because negative 2 over 1 is the same thing as 2 over negative. Okay? All right, one more. Graph the line that contains the point P, which is at negative 2, 1, and is perpendicular to line JK. Okay, and it says that J is located at negative 5, 4, K is located at 0, negative 2. So I'm going to go through the point negative 2, 1. So that means from the origin I go 2 to the left and up 1. So it's going to go through that point, right? But then it needs to be perpendicular to this line JK. Okay? What do I need from this line JK? I need the slope of that line so that the slope of the line perpendicular to it is its opposite reciprocal. Okay? So let's look at the slope of JK. Okay, so again, slope, difference in the y over the difference in the x's. That ends up being 6 over negative 5. So the slope of JK is negative 6/5. My line is perpendicular to it, so what's it going to be? It's going to be the opposite reciprocal. So I flip it and change its sign. So it's going to be 5/6. So then I come over here, and from that point, I rise and run 5/6. So from that point, I go 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5, 6 to the right. Okay, and so this line is perpendicular to JK. Now, it didn't say that I had to draw JK, but if you wanted to double check and make sure you were working right, you could plot those 2 points, 1, 2, 3, 4, 5, 1, 2, 3, 4. There's J, and K is located at 0, negative 2, and you can see that those lines are perpendicular to each other. Okay? What if they wanted it to be parallel? You'd use the same slope, right? But since it said perpendicular, you want the slopes to be opposite reciprocals. All right, any questions? Pretty sure you covered all this in Algebra 1, right? Some of us may have been really good at it. Some of us may not have been. Hopefully, if you were in the second category, that you'll get better, okay? All right? Okay, because you're going to use this now, next year, the year after that, the year after that. So it's something that you're going to keep seeing. All right.